Hello, this is Kayla Morrison, and this is a video on OLS regression. Ordinary least squares, or OLS regression, is used to determine the linear relationship between x and y. OLS regression is sometimes referred to as linear regression. The formula for calculating OLS regression is y equals a plus bx, where a is the y-intercept and b is the slope. Within this equation, the formula for b is the sum of x minus x bar times y minus y bar divided by the sum of x minus x bar squared. The formula for a is y bar minus b times x bar. So let's walk through a sample calculation together of OLS regression, comparing time spent studying versus final grade in a class, where the independent variable, x, is the time spent studying, and the dependent variable, y, is the student's final grade. Here we have the data we collected, with the students listed down the left-hand side, weekly time spent studying in hours down the middle, and final grade in percentage form down the right-hand side. When we're using OLS regression, we make the assumption that our data would plot in a linear fashion, as you can see here. Now we can begin to work towards our OLS regression formula, beginning with b. We start with the x minus x bar part of this equation, where x is the weekly time spent studying in hours, and x bar is the average of those times. Here, our x bar is 2.67. We subtract x bar from all of the x values as shown here. Now we find the y minus y bar part of this equation. Again, we find the average, y bar, of 74.3. We subtract the y bar, 74.3, from all of the y values as shown here. We continue with this equation by multiplying across the values for x minus x bar times y minus y bar. For example, with student 1, we would multiply 1.33 times 8.7 to get 11.571. We continue with this for each student and then sum the value. Here we get 495.280. Now that we have this value, we can put it in for the sum of x minus x bar times y minus y bar. Our equation now reads b equals 495.280 divided by the sum of x minus x bar squared. We already have the values for x minus x bar. Now what we have to do is square these numbers. For example, 1.33 squared is 1.7689. We now find the sum for all of these values of x minus x bar squared. Here we get 70.362. We can now add that into our equation. Our equation now reads b equals 495.280 divided by 70.362. We simply divide these values, and we obtain a b of 7.039. Now we can move on to the value for a. Again, our equation is a equals y bar minus b times x bar. We actually already know these values. We just calculated our b as 7.039. We also plug in our x bar of 2.67 and our y bar of 74.3. Multiplying the 7.039 times 2.67, we get 18.794. We then subtract that value from 74.3 to get an a value of 55.506. We can then take both our A and B values and plug them into our OLS regression formula. Now our formula reads y equals 55.506 plus 7.039 times x. Now that we've completed one together, why don't you try it yourself? Here's some data comparing the level of anxiety to time spent reading in hours per week. Complete the OLS formula and compare it to what I have posted below this video. Thank you for watching and have a great day.